Assalamualaikum and hello. This is the summary for types of reaction in organic chemistry. The first thing first, what you have to understand is how to identify the molecules given acts as electrophilic side or nucleophilic side. So, in order for you to understand that, we are going to go one by one. For electrophilic side, there are molecules with low electron density, and what you should take a look at is the presence of polar bond. If the molecules given has the difference in electronegativity between carbon with another atom such as oxygen or halogen, you can see that there is a polar bond between those atoms, and of course there will be the difference in electronegativity between two atoms that I mentioned before. For example, we can see that the carbonyl compounds, they have C double bond O, where you can see the difference in electronegativity between carbon and oxygen atom, where oxygen is more electronegative than carbon. Same goes for haloalkanes. As you see from here, carbon atom attached to halogen, the symbol is X as general. You can see that halogen, all of them are in group 17, and of course they are more electronegative than carbon atom. And last one, we can see the difference in electronegativity between carbon atom and OH group in hydroxy compounds. For example, alcohol. You can see carbon is more electropositive than hydroxyl group. So all of these compounds are examples of molecules that act as electrophilic side. For the next one, we are going to take a look at the nucleophilic side. Nucleophilic side is the opposite for electrophilic side, where they are molecules with high electron density around carbon-carbon multiple bonds. The multiple bonds that I mentioned here, I will emphasize them as alkenes, alkynes, or benzene ring. The benzene ring usually exists in aromatic compounds. So these three are examples of compound that can act as nucleophilic side. Now, from there, we are going to continue how to determine the type of reaction based on reactants and products. This is just the summary. If you still remember from the previous video, I taught you about how to identify the big molecule and the small molecule based on the reactant side. So now we are going to use the reactant based on the big molecule. For example, let's say I got alkene as my big reactant molecule, where you can see there is a presence of carbon-carbon double bond in alkene. So, due to the presence of multiple bonds, alkene is considered as nucleophilic side because it has higher density of electron. Then alkene will attack the electrophile from this double bond. And what's next? This double bond will break down and another two single bonds will be attached to the electrophile. So we know that the number of carbon atoms stay as it is, but the number of bonds increasing. So of course the number of atoms also increasing. So that's why this type of reaction as general is addition. So that's how you write it down for your answer. But in order for you to determine the specific name, you are going to take a look at the product side. So at your product side, it is very important for you to determine the correct reagents that is being added or substituted. For example, in this case, you know that electrophile is added at extra 2 bonds here. So we can conclude that the specific name for this type of reaction is electrophilic addition. Now let's continue with carbonyl. Carbonyl, we know that there is a presence of C double bond O structure in its compound. And you know from here, carbon is more electropositive than oxygen. So oxygen has partial negative charge. So due to the partial positive charge at carbon atom, carbonyl is considered as electrophilic side. So due to this characteristic, what will happen? This carbon will be attacked by nucleophile. So something else will be added. That's why you got the same number of carbon but increased number of atoms. So the name for type of reaction for this example, carbonyl compounds, is addition. And what's next? We know nucleophile is added at the product side. So the specific name will be nucleophilic addition. Next one. If I say I got alcohol as my big reactant molecule, or haloalkane, or another compound with CN group attached to it, this group of atoms are example of partially negative atom. So there will be negative charge on them. And what's next? In logic, they will attach to something else in partially positive. So you can conclude this reactants has polar bonds because due to difference of electronegativity. So any molecules with polar bonds are considered as electrophilic side. So this one, I will write it down as electrophilic side. And from here, you can see that there is a change of functional group. Why I said like that? Because from OH group, it changed to X, halogen. From X, it changed to OH. And from CN, it changed to OH. So you can see there is a change of functional group. And from here, we can understand that this group is being replaced with another functional group. So, as general, that type of reaction we call as substitution. And if you want to write down the specific name for this one, you have to take a look at the big molecule, our reactants. At this side is electrophilic side, and what change is depending on your big reactant molecule. For this case, electrophilic side here will be attacked by nucleophile. So, nucleophile replace at this electrophilic side. So, the specific name will be nucleophilic substitution. Let's continue with the next one. For the next one, let's say we got alkane. So alkane is an example of hydrocarbons. So if you got alkane as your big reactant molecule, alkane will undergo only one type of reaction to form the product haloalkane. And this reaction will be conducted under condition sunlight or UV. As I mentioned in the previous video as well, if you realize your equation or reaction has presence of sunlight, we can straightaway determine the type of reaction, which is free radical substitution. So I hope all of you can memorize this part. Very special because you need UV or sunlight. Next one, for example, I got alkane or any single bond containing compound, and what will happen from single bond, the number of bond is decreasing and they will form the multiple bond containing compound as the product. You can see that the number of carbon chain stays as it is, but the number of atoms decreasing. So this type of reaction, there is only one answer for this one, which is elimination. So, from single bond to double bond, please memorize they can only undergo elimination. And elimination doesn't has specific name because it only exists as elimination. There is no nucleophilic elimination, there is no electrophilic elimination. That is totally wrong concept. So please remember that. And now let's continue with the last example. I got aromatic compound. So aromatic compound, the reaction only happen at hydrogen which attached to the ring. So for aromatic compound, you know that this compound contains benzene ring. For example, I take the benzene itself as an example with its molecular formula C6H6. So I know my final type of reaction, I will put a word aromatic. And now, you want to do the reaction for aromatic compound. Please remember, benzene ring has high electron density. So this one, we will consider it as nucleophilic side. So it means that this nucleophilic side will attack electrophile from another small reactant molecules, which making there is a replacement for another atom with this hydrogen atom. So that's why I put question mark here to replace any atoms that can replace hydrogen atom here. That atoms or groups can be NO2, nitro group, or can be halogen such as fluorine or chlorine. So it depends on the question given, but I hope you all understand there will be a change at this position. So the molecular formula will be C6H5 less one number of hydrogen and continue with another what you replace at this position. So I put it as question mark here. So from here we know that this is nucleophilic side and nucleophilic side will attack electrophile. So at your product you can see these groups or atoms attached here are considered as electrophile. So the specific name depends on what is substituted. In this case, we know the type of reaction as general is substitution. But from here, we can write the specific name. Electrophile is substituted here. So the full specific name will be electrophilic aromatic substitution reaction. So I hope all of you can master this last subtopic where you have to know how to identify and give the name for the type of reaction for any examples or questions that you found. Try to do a lot of exercise, and that's all for this video. I hope this helps you to strengthen your knowledge about type of reaction. Till then, I'll see you in the next video. Bye!